Hello students, we're going to be looking at our last boot camp, which is based on doing some graph analysis. This is really going to be focused on getting us ready to make the transition into limits from pre-calc stuff, and really focused on talking in the same language in terms of using phrases like positive versus negative, increasing versus decreasing, and concave up versus concave down. Once we kind of can use the same language, it's going to make some of the stuff we do later this year a lot easier. The first part about this is going to be two different explorations, both of which are going to be through Desmos. There are links to this in Classroom. Once you complete each of these two separate explorations, we're going to begin talking about some specific problems. This might take a full class period, it might take a little bit less than one, but we've got a couple of periods to work through all this together. So dealing with increasing and decreasing, hopefully working through those explorations let you have some kind of a clearer discussion of this. So increasing, we're talking about going anywhere that from left to right, we're going from bottom to top. So that's these two places here. The first interval I'd say would be from negative infinity up until that looks like 1, 2, 3, so negative 3. And the second interval would be from 1 up until 1, 2, 3, 4. We always use x values to talk about intervals, not y values for these. And then decreasing, well, that's going to be this part in here. And that's going to be from negative 3 to positive 1. And we're constant anywhere after 4. So it looks like from 4 to infinity. For our bottom graph, let's take a look at increasing first. So we're increasing here, we're increasing here, and we're increasing here. Those intervals, 1, 2, 3, 4, 5. So from negative 5 to negative 3, in union with negative 1 to positive 1. And also from 1, 2, 3, 4 to 5. We're decreasing at the beginning of this graph and then here. So that's looking at 1, 2, 3, 4, 5, 6, 7. So negative, actually that looks like we've got an arrow there that I was not seeing because I was covering it with green. So negative infinity up until negative 5, that's where we start increasing again. And also from 1 to 1, 2, 3, 4. Okay, and then we're constant. We have two intervals this time. We're constant from negative 3 to negative 1. And then also from, it looks like, 5 to infinity. The other piece of this is that we have to be able to talk about positive and negative intervals, and intervals that are concave up or concave down or neither. Let's talk about positive and negative intervals on here. So negative we know is anywhere below the x-axis. So in our first graph, this looks like we're negative, going from negative infinity up until 1, 2, 3, 4, maybe negative 4.2. And then again, and this time we're negative all the way up until it looks like 3. So maybe negative 1.1, because that looks about right, and going up until 3. That means that we are positive in our other intervals here. So between negative 4.2 up until we get to negative 1.1, that's going to be this part in here. And then again, after we pass our 3-ish point up until infinity. Talking about concavity, parts that were concave down, it looks like we're concave down maybe up until about there. The next part's concave up, and I have covered this with so much marker that I can't really tell that's still concave up there. So concave down from, looks like we're going to keep going that direction, so negative infinity up until negative 1.1-ish. That's about where it changes sign to. And then concave up from negative 1.1-ish up until we change into a linear function, which is 1, 2, 3, 4. And then neither concave down nor concave up would be after that point. Just for lack of space, I'm not going to do that for the bottom part here. You can handle that part on your own. For the problems on this page, our goal is to figure out if these things are true or not. So for example, from negative 8 to negative 2, so here to here, are we increasing? Yes, we are. From negative 8 to negative 2, we are always going from, as we go from left to right, up. From 2 to 10, we are not increasing because we are both decreasing and then increasing during the interval. The intervals where f is increasing, it looks like from negative infinity to negative 8. That's our first interval. And I like that I immediately did that for the opposite one. That's going to be in the one below that for decreasing instead. So negative infinity to negative 8. We are increasing from negative 8 to negative 2. That was the answer to the first question. Then we're decreasing from negative 2 to 0. We're increasing from 0 to 2. We are decreasing from 2 to 5. And it looks like we are increasing from 5 to infinity. Local maximum. So we're looking for points that are maximum values. We've got one here and we've got one here. These are our local maxima. And all that means is that they are higher than all the points that are immediately around them. So x values are at x equals negative 2 and x equals 2. Local minimums, or minima, that's going to be here and here and here. Any place that those are lower than the points immediately surrounding them. So those are going to be x equals negative 8, x equals 0, and x equals 5. X-intercepts, I've got 1, 2, 3 at negative 5, 0, and 5. And the y-intercept is at the point 0, 0. Your goal here is to draw functions that have some of the following characteristics. These are going to be things that look different based on kind of your interpretation and how you draw your graph. But in terms of this, there are a couple things that we can use to kind of make some sense here. So we can see that we have some increasing and decreasing stuff going on, and at 2, that's going to change. So if we're trying to find increasing on this and then decreasing afterwards, our graph is going to look something like this. There's a second part here where it says that f of x is also all positive on this interval. So my graph doesn't work because it goes below the x-axis. In order for this to work, it would have to be something that was more like this, where we have a gradual slope up and then a gradual slope down. And you might notice that those are kind of curving towards an asymptote. So we are always increasing or always decreasing, but at the same time, we're never going to cross the x-axis. For all of these things, you're going to have similar kind of thinking here. So I might do the same thing. So we've got some kind of break at 2, increasing and concave up from negative infinity until 2. And then so something like this. And decreasing but positive on the interval from 2 to infinity. So this could be something that actually fits this exact same thing here. For the first one, we could also have gone below the x-axis here because we know nothing about this being positive, so something like that would have worked too. These could meet in the middle, or that could be an asymptote. Either one of those would end up being okay. I'll let you play with the other two on this page to see what you create on your own. All right, we've got a whole bunch of stuff to find out here. We've got to find domain and range. and domain is going to be all the x values that we see on our graph. In this case, we're going from -4, and we include that point up to +4. The range has a low point of 0, and we are including that, and a high point of 3. The x and y intercepts, x-intercepts are going to be at -2, 0, and at 2, 0. Y-intercept is going to be at 0, 3. Intervals of increase, that's going from -2 to 0 and from 2 to 4. And intervals of decrease, those are my other ones, going from -4 to -2, and then again from 0 to 2. Intervals of constant, there's no constant interval on here. Positive, negative values, we are positive except for our 0 points everywhere on our graph. It's not negative anywhere. X values of local extrema, so that's these points. They are all extreme values that are either higher or lower than the surrounding ones. And then we have a new phrase here, which is global or absolute extrema. So that's the overall highest or lowest points. The highest point overall is going to be at 0, 3. The lowest points overall are going to be at -2, 0 and 2, 0. So those would be both global and local values, or local extreme values. Similarly, on this page, we're going to do the same type of thing, identifying domain and range and stuff based on graphs, and take a look at this that way. Number 12 is kind of tricky because if you assume this is just going to keep going this way, its domain is going to be drastically different than if you assume that it's going to keep curving and end up having an asymptote there. Either way is a totally fine interpretation, and either way will work for this problem. Here's some more stuff on max and min values, highest and lowest parts of our graphs, and trying to make some sense of that. All of these graphs keep going past our what we can see on the graph, so please take that into account when considering max and min values. This is more of the same stuff, where we're finding increasing, decreasing, constant, positive, negative, and in this one we're not doing concavity. More of the same, and more of some sketching stuff. This one gives you a few points to use, so let's just talk about that. So we have to have f of 0 equals 2. We have f of 3 equals 0. We have f of 5 equals 0. We have some description of this being increasing. Sorry, f of 5 doesn't equal f of 3. F of 5 equals f of 0, which is actually 2, and that makes more sense. And then we have some stuff about this being continuous, that's also increasing sometimes and decreasing other times. We've got some ideas about minimum values of things. We got to be a little bit careful in terms of these graphs are not continuous. And that means we have some questions about like this last one, where we have a minimum value here, but then this one keeps going forever. So that would be an example of not having a minimum value. More discussion of absolute and local max and mins. And that's continuing through the last couple slides.